Now, what is the energy signal? What is the power signal? Suppose our input, suppose a discrete time sequence x of n, then the energy can be defined as E of x or epsilon or x, epsilon of x, summation n equal to minus infinity up to infinity x of n modulus square. This is the energy of a discrete time sequence x of n. Mainly, if this x of n is a periodic signal, then its energy is tending to infinite. Means if the periodic signal from minus infinity up to positive infinity, then the energy of the sequence will be infinite. Then what is the power of the discrete time sequence? The power P of x is limit k tending to infinite 1 over 2k plus 1 summation n equal to minus k to k x of n modulus square. Means summation n minus k to k x of n modulus square. This is the actually it's represent a energy. We divided by the time means 2k plus 1. Now we get the power. Here we written k is tending to infinite, 2k plus 1 because of n is minus k to k, means there are 2k plus 1 number of sequence. So we divided on 2k plus 1, and this is the energy terms. Energy divided by time also is the power. This is the power of discrete time sequence. For a periodic signal of period n, then the power can be written as this 1 by 2k plus 1 is replaced by n, where n is the period, and here x of n's modulus square, where the n is from 0 up to n minus 1. This is the limit of the n. N is up to 0 to up to capital N minus 1, where the capital N is the period of the sequence. This is the power for the discrete time periodic sequence. Okay. For the energies for the periodic signal, the energy is 0. For the periodic signal, the power is 1 over n summation n equal to 0 n minus 1 x of n modulus square. What is the partial energy? Partial energy means epsilon xk, here from n is minus k to k, a modulus of x of n square. Energy means we take n from minus infinity to infinity, but for the partial energy we will take for a particular segment, means n is minus infinite minus k to k. This is a partial energy. For the partial energy, partial power, limit k tends to infinite, partial energy E epsilon x comma k divided by 2k plus 1. This is the partial power. So for the periodic signal, energy is tending to infinite. For the periodic signal, power is the finite value, and the power is 1 over n summation of n equal to 0 up to n minus 1 x of n modulus square, where the capital N is the period of the signals. Next, what is the next another terms for the finite duration signals? In case of periodic signal, the duration is infinite, but in case of finite duration signal, the power, then the energy is finite and the power is tending to 0. If a signal is finite, this energy is finite and power is 0, then it is called as a energy signal, and the energy signal always decaying in nature. This is the energy signal. But here we discuss there the power signal. Here the energy is the infinite, but the power is the finite. So the signal is called periodic signal. So this periodic type signal is called as a power signal. Power signal means this type of signal will be periodic signal. Here power is finite, here energy is infinite, and the power is written by this formula. In case of signal where energy is infinite, energy is finite, power is tending to 0, and energy is from this formula. Energy is from this formula. This is called the power. This is called the energy signal. Energy signal always be decaying in nature. Okay.